Okay, we're looking at question 5. Question 5. So let's try and do question 5. Okay. Here we have state the domain and range of each. Okay, so here it looks like it's going forever. So let's turn this into a little bit colorful. So how do I do this? I put a set notation. And I say x element of real numbers. And that's it. Okay, that's a domain. The range is also element of real. Now I always make the mistake and say x. Make sure when you're talking about the range, you're always saying y. Now this one is the absolute value function. And the way this is done is it goes on and on forever in the positive direction, up, and in the negative direction in the x direction. So it takes on all x values and all positive y values, but there's no y value past 0. So what can x be? That's how you answer these questions. Domain is a set of x values such that x is element of R. And here the range is simply x is an element of R such that, oops, I just said I make that mistake and I just did. Y is an element of R such that y is greater or equal to 0. Okay, and don't write in your textbooks, obviously, but because I'm doing it, maybe you think it's okay, but this is not a textbook. Obvious again. Here, we're doing C now. Now, let's see. What's the x? It goes here, but it doesn't go there. So the domain, in this case, is set of x element of real numbers such that x is greater or equal to 0. Okay, greater or equal. This is greater or equal sign. What about the range? The range is a set of y values element of real numbers. Now, can y be anything? Yes, it can. It literally goes forever in both directions. Therefore, that's all we need to do for range. Okay, let's look at D. Look at the y values. Sorry, let's look at the x values. It essentially goes in every direction. So the domain is set x element of real numbers. And the range actually, it's y element of real such that y is less than or equal to, right here, -1. Okay? And finally, we'll look at D. Right here, there's an asymptote. There's an asymptote. Why? Because x can never equal 3. If x, look at this, if x was to equal to 3, then y is equal to 2 over y minus 3. Sorry. X take away 3. Or y is equal to 2 over 3 minus 3, which is equal to 2 over 0. That can't be the case. So x cannot equal 3. So the domain becomes x is an element of R, real numbers, such that x unequal to 3. What about the range? Oh, look. It goes in every value. It goes all the way down. It goes all the way down. It goes all the way up. Unfortunately, not unfortunately, it just so happens to be the case that x cannot equal 0. That's another asymptote. And if we look at the graph, ask yourself, what value of x can make this 0? And the answer is nothing until it gets to infinity. That basically, we're dividing 2 by a really, if we divide 2 by a really, really, really big number, we'll get very smaller. We'll get smaller and smaller y values, but it will never equal 0. So the range is x is an element of real numbers such that x, oh, I did it again. Y is an element of real numbers such that y never equals 0. And that's question 5.